Theoretical probability is probably what you most think of when you think of probability. Before we looked at experimental probability. That was based on what has actually happened. Here's the experiment, here are the results. Theoretical probability is based on what should happen if everything is fair. Theoretical probability is defined as the ratio of number of ways an event can occur to the number of equally likely outcomes. So it's how often can I roll a 4 on a number cube? I have this spinner with 5 choices. What is the probability that I would spin a 2 or a 3? That is theoretical probability. Equally likely, that's part of the theoretical probability definition. Equally likely means all the outcomes have the same probability. It is a fair experiment. So an example of something that would not be fair, if I have a spinner and this one piece of the pie is valued at 1 and the other piece is valued at 2, this is not a fair spinner because you can tell by looking at it I am more likely to spin a 2 than I am a 1. So here's a question for you. What is the theoretical probability of rolling a number greater than 2 on a number cube? So you have to start by thinking of what is the probability of a number greater than 2. That would be numbers 3, 4, 5, and 6. That is 4 ways. So the ratio of number of ways an event can occur. So there's 4 ways I can roll a number greater than 2. That's compared to the number of equally likely outcomes. There are 6 possible outcomes on a number cube. That reduces to 2/3, and rounded, that's the decimal 0.67 or the percentage 67%. Here's another situation for you. There are 14 boys and 16 girls in a class. So what is the probability that Miss Staley will randomly call on a girl? Like picture I have a mason jar with popsicle sticks of everybody's name on it. What is the probability that I will randomly pull out a girl's name? So probability of a girl, that's the event, that's going to be equal to the number of girls in the class compared to the total number of students. Notice I didn't say number of girls to boys. Is compared to the number of equally likely outcomes. So there's 16 girls. To find the total number of students, I add girls and boys because they are complementary events. It's either one or the other. So that's 16 out of 30, which reduces to 8 over 15. If I wanted to find the probability of a boy, I can use what we've learned about complements because that's the complement. So the probability of the boy plus the probability of a girl is 1. So probability of a boy plus 8 over 15, which we found was the probability of randomly calling on a girl, is 1. So I can subtract that and I get 7 over 15 for the probability of calling on a boy. Here's some practice for you. For each question you have a situation and then there's 3 different probabilities that you're finding. On part B there's 2 different probabilities that you're finding. Go ahead and pause the video, attempt this, and then we'll compare. Practice A is talking about a set of cards that has 15 yellow cards, 10 green, and 10 blue. So what's the probability of choosing first? A yellow. There are 15 yellow cards, and for the total number of possibilities, you add 15 plus 10 plus 10, and you get 35. So 15 over 35 simplifies to 3 over 7. The green cards, there's 10 of them. There's 35 altogether. That simplifies to 2 over 7. The probability of it not being a yellow or a green, then that means it is a blue. There are 10 blue cards, so 10 out of 35 is 2 over 7. Or you may have thought of that as a complementary event. 5 out of 7 cards are either yellow or green, so the ones that are not yellow or green would be the complement to that 2 over 7, because the 5 plus the 2 is 7. Part B, find the probability when 2 fair number cubes are rolled. So first it has a probability that the 2 number cubes have a total of 3. So I could roll a 2 and a 1 or a 1 and a 2. Those are my possible combinations. So that's 2 out of 36. 36 comes from me using the fundamental counting principle. If I'm rolling 2 number cubes, that means I have 6 outcomes for the first number cube and 6 outcomes for the second. Fundamental counting principle says I can multiply 6 times 6 to get 36, and then that simplifies to 1 over 18. You could have made a huge tree diagram and shown all the possible outcomes and then looked through there and saw the ones that could total 3, and there's only 2 of those. For number 2, a probability with a total of 13. Well, since the top number is 6 on a number cube, 6 plus 6 is 12, there is no possible way that I can get a total of 13, so the probability is 0.